Hello and welcome to my presentation today. My name is Markus Goetz and I'm a researcher at the Department of Conversion Technologies and Biobased Resources at the University of Hohenheim in Stuttgart, Germany. In the team of Professor Kruse, we are developing decentralized regional biorefineries. We call them on-farm biorefineries to produce valuable chemicals and materials such as plastics from agricultural residues. In the next few minutes, I will guide you through the development steps from the field to the lab to industrial applications and products. First, why are we doing this? Rising greenhouse gas emissions and the resulting climate crisis are forcing us to rethink the use of fossil resources and to stop using them. In other words, the carbon source from which we produce chemicals and materials must be renewable. This can be done via CO2 or via carbohydrates. We are talking about a real revolution. Our fossil-based economy has to be transformed into a bio-based circular bioeconomy. Biorefineries can be a tool for this. Biorefineries produce several products for the bioeconomy. In the process, biomass main and side streams are refined into food, feed, materials, chemicals, and energy through efficient cascade use along the process and value chain. The utilization of residues and byproducts is important in order to avoid competition with food and to close nutrient cycles. Nevertheless, the whole thing should also be economically attractive and contribute to stronger rural areas. The basic concept shown here shall explain that some of the feedstock is used to generate the heat and electricity needed for the plant itself, and the circularity of our concepts by extracting the nutrients and bringing them back on the fields to grow new biomass. Let's take a look at the example of chicory, winter salad and vegetable. But the concept also works with other carbohydrate-rich residues such as grasses, cereal straw, or others. The upper part, the lettuce, is eaten as food. The root is very bitter and can therefore hardly be used as food or feed. At the moment, it mostly ends up in biogas plants. The root still contains a lot of valuable long-chain carbohydrates stored called inulin, a polyfructose. If this inulin is converted in hot water about 160 to 200 degrees Celsius under pressure in a so-called hydrothermal process, it's like a steam cooker, a chemical is produced that smells somewhat like caramel. This chemical is called hydroxymethylfurfuran, or HMF for short. As already mentioned, this also works from other carbohydrates such as starch or cellulose. HMF is a versatile chemical and is one of the most important platform chemicals or bulk chemicals of the bio-based future. Because of its two functional groups, it can be used to make many other chemicals and products. For example, plastics such as nylon or polyethylenfuranoate. Polyethylenfuranoate, PEF, is similar to the well-known fossil-based polyethylene terephthalate, PET. However, not only is it green, bio-based, and more sustainable, it also has better properties. For example, the gas barrier for water vapor, CO2, and oxygen are higher. The reduced permeability makes recyclable monomaterials possible. In the area of food packaging, this means, for example, that the packaged food has a longer shelf life. The best before date is longer, less food has to be thrown away, but this material is also very fascinating for fibers. We are currently developing the process to industrial scale. We are out of the lab. The small autoclaves labeled with 2015 and the semi-continuous mini plant labeled with 2017, and are currently operating and optimizing a small pilot plant at one of the agricultural research stations of the university, the Untitled. The next step towards industrial production is a demonstration plant, which we would like to realize as soon as possible, maybe also with your collaboration. At the end of my presentation, I want to summarize with a video to show you also some of our other activities. Here you see also the link to our website. Here I am again, and here you see some impressions of our lovely university. And if you should ever be in Germany and in the region of Stuttgart, we would be very happy to invite you to come and visit. Thank you very much, and please visit our website and write us an email if you're interested in further information or in doing some bioeconomy